All right, so number one on the homework. Let's see what we got here. Angela took a general aptitude test and scored in the 90th percentile in the aptitude for accounting. So, what percentage of scores were at her or below her score? Well, if we look at the definition of percentile, percentile tells you what values are at or below your score. So, P% of the data fall at or below your score. So, that means 90% of her data falls below her. So, that means 10% of the students or the people scored above her on the test. So, 90, 10, different numbers there. All right, two. Clayton and Timothy took different sections of Intro to Economics. Each had a different final exam. Timothy scored an 83 out of 100 and had a percentile rank of 72. Clayton scored an 85 out of 100, percentile rank of 70. Who performed better with respect to the rest of the students in the class? So what we're talking about is with respect to the students. So how do we measure with respect to students? With respect to the others in the group, we use the percentile. So the percentile will be the measure that we use. So we're looking for who had a higher percentile. So Timothy had a percentile of 72. Clayton had a percentile of 70. So Timothy's is going to be better because his percentile was higher. Okay, so if you're wanting to do better relative to the class, respect to the rest of the class, you want to compare the percentiles. So even though Clayton had a higher score, Timothy's percentile was better. Okay, number three, we've got a few options here. You could do this by hand or you could do it in the calculator. I'll just do this in the calculator. We did talk about how to do this by hand, but it's not that bad to do by hand. It's all in order. So I go to second mode to get out of here, stat enter, clear down. If I go to the top, press clear, then press down, and I'm going to enter this data set in here. So you could use your calculator. You are welcome to do this by hand. It's not that bad to do by hand because it's a pretty simple data set. It's in order. There's not many data points. So find the low, Q1, median, Q3, and the high. That's the 5-number summary. We could do that. Well, you know what the low and the high are, but I could go to one bar stat. Let's go right to one bar stats, L1, press enter. The 5-number summary is when you scroll down here, and so it's just sitting at you right there. So 6, 9, 11, 6, 9. Just make sure, double check and make sure you enter in the numbers right. Hopefully I did, because I didn't double check, so, because this is not a hard question. Don't have Salt here to help us. So the median's the middle one. We have 9 points, so 11's in the middle. And then the Q1's the median of the lower part, so the median of these four, which is 9. Q3 is the median of the upper part, so it's between 12 and 13, so it's 12.5. The lowest is 6, the highest is 14. What's the interquartile range? That's just Q3 minus Q1, so 12.5 minus 9, so that'd be 3.5. Make a box and whisker plot for the data set. So you could go off the 5-number summary here, or you could go off your calculator. Now, I recall on the notes, I already set this up. Second y equals, I turned plot 1 on, and I selected the box plot with outliers option. So once I'm done with here, I can press second mode to get out of there, and then zoom 9. And so I can look at the box plot. The median's going to be at 11. Okay, the minimum should be at 6. They all have a minimum of 6. Q1 should start at 9, so Q1's at 9, Q1's at 9. It's not going to be the second, or not going to be the third one, not going to be the fourth one. So now I'm down to these two. The median's at 11, so it's got to be that one. The Q3's at 12.5, and the high is 14, so it's got to be this one here. Okay. So pretty simple, straightforward there. All right. So on number 4, we're going to do some analyzing of box and whisker plots. And so we've got Consumer Reports rated automobile insurance companies and gave annual premiums for top-rated programs in several states. The figure shows box plots for annual premiums from a calculator. So they gave you the calculator. Which state has the lowest premiums? So which one has the lowest and which one has the highest? So the lowest, I have to squint in here to see this. Which one's lower? So you're looking for the smallest minimum. So which one has the smallest minimum? Looks like by a hair it's California. which one has the highest premium? The highest premium would be the highest max, and that'd be Pennsylvania. So lowest, California, highest, Pennsylvania. Okay, so I had to squint in there to see that. Which state has the highest median? So highest median, you're going to look at which one has the highest the vertical segment within the box plot. So which one's got further along? It's Pennsylvania. You see Pennsylvania's above California and Texas, so Pennsylvania. Which state has the smallest range of premiums and the smallest interquartile range? The smallest range would be, I'm looking at the length of the whole box, and which one has the small, which one's whole, entire box is the small, has the smallest length. So if we're looking at which one has the smallest length, looks like California has the smallest length entirely. So California has the smallest range of premiums. What about the smallest IQR? The smallest IQR would be the smallest length inside the box. The IQR is the distance inside the box. Which box has the smallest length? That'd be Texas. So California has the smallest overall length because it's from bottom to top. It's the smallest range. It's got the smallest range of values. And then which one has the smallest box length? That'd be Texas. So that'd be the smallest IQR. So IQR, smallest range, California. Okay, D, if the other set of figures show the five number summaries, match these correctly. So let's look at first the smallest min. We already established the smallest min was California. So California has to be C because it's the smallest min. Okay, and then the next smallest min was Texas, so Texas got to be A. I'm just going off the minimums, and then Pennsylvania's got to be B. So you see how I'm just going off the minimums. California is the smallest, Texas is barely a little bit bigger than that, and then Pennsylvania is the highest minimum. So it'd be C for California, A for Texas, and B for Pennsylvania. Okay. So that's a what you could go also. You could go to pick on any of those values you want. You can go look at the medians and compare the medians. It's not too bad. Okay, so all right. All right, some data sets include a value so high or so low they stand apart. We talked about that in the notes. It's called outliers. So it might be a data collection error, it might be a data entry error, somebody might have made a mistake, or just an unusual value. So there's a formula to do that, and so the IQR helps you as well. So we've got Minitab has produced these, and so we're going to look at the make a box and whisker plot from the data. So what I would do is I would just do this in your calculator. You could do this by hand, but it's just a lot easier to do this in your calculator. So I'm going to go split screen here. Stat enter to get to this point. So I'll go back there. Stat enter. Then go to the top, press clear, press down. There's probably some online ways to do this too, so we don't have salt. You could do this using Google Sheets for 55, 75, 73, 67, 71, 62, 52, 66, 63, 80, 61, 64, 74, 65. Okay, so there's your, and we had 24 data points. Okay, and we all have the same data set here. So make a box and whisker plot. Now, recall earlier I went to second y equals plot 1. It's already on, so you go second y equals and make sure it's on. And you don't have to do this every time. I'm just showing that I did that already. So I'm going to press zoom 9. Now, I do have an outlier. That value of 4 is an outlier. Now, I'm a little concerned about this because, okay, they did not plot the outlier. Okay, they did not plot the outlier. And so traditionally we would plot the outlier. So make a box and whisker plot. Well, what happens here is this outlier, as you could see, is not connected. I'm going to delete this out of here. Back to graph. This outlier is not connected to the rest of the data set. So we're going to look at the one that doesn't have an outlier, and I'm going to press trace. So this should not be connected. So the whisker, like, this is wrong. This is wrong. It should not be connected. So my first whisker should start at 50, which this is a little misleading here. I'm not sure why this is like this. Well, all right. They did not. I don't agree with this. They did this. They picked the one. They picked this one here, but that's not the. I'm just going to say this. That is not the proper way to draw a box and whisker plot. If you have an outlier, you're not supposed to connect it to the data set. I'm uncomfortable with that, but you're not supposed to connect it. That's not right. But well, that's right for a certain type of box and whisker plot, but not for the type that we're doing. So, anyways, we're just going to select that one, but that's not the proper way to do it. The IQR is Q3 minus Q1. You could define this in the calculator. If I go up to Q3 or Q3 is 71.5, Q1 61.5, so 71.5 minus 61.5, that'd just be 10. So all I did was find Q3. I could do one bar stats, but I could just look at the graph there. Multiply and find the lower and upper limits. Okay, so I need to do a little work here. So my Q1 is 61.5. I'm going to go back here. 61.5 minus 2 times 10. So 2 times the IQR. That gives me 41.5 is my lower limit. And then my upper limit was 71.5 was my Q3 plus 2 times 10. So that'd be 91.5. So the question is, do we have it? Oh, I didn't do something right here. IQR was 10. Oh, multiply by 1.5. I don't know why I did by 2. I'm so sorry. I meant to do 1.5. That was my mistake. 1.5. 1.5 is correct. Multiply by 1.5. I apologize. I don't know what I was doing there. Lost track, lost focus there. A6.5. So, are there any data sets below the lower limit? So, do we have any that don't fit? Well, obviously, we have that 4 that doesn't fit. So, yes. And so, that 4, we'd have to say that 4 is probably an error, like either an error or just a really bad observation. We're talking about we're talking about the. So what are we looking at? Oh, heights and inches. So heights and inches, would somebody be 4 inches? So what happened was the person that was collecting data just made a mistake when they were entering the data. They probably made a mistake, and that was the. All right, 6. Next, we've got SALT here, so we don't need this anymore. A hospital is concerned about high turnover rate of nurses. A survey was done to determine how long nurses have been in their current positions, and so I can click use SALT. Okay, I'm gonna do 2 windows on this. So once I click use SALT, I'm going to go to charts and graphs, and I'm going to select the variable, months and current positions, and I'm going to select box plot. Okay, so box plot, and what it does is it plots it for you here. I need to zoom out a little bit so I can see this if I can. I guess I'm going to have trouble seeing this. So my minimum is at 10. My Q1's at 17.5, so let's see if I can match that. Minimum at 10, Q1 at 17.5, so these are all reasonable. 31's my median, so 17.5, right? 17.5, 31's my median, and then my max is 50. My max is 50, so at my 36.5, 36.5, this one's not going to be 36.5. That 36.5 is off, so it's got to be this one. You see the minimum's at 10, 17.5, 31, 36.5, and then 50. So find the interquartile range. The interquartile range would simply be 36.5 minus 17.5. So 36.5 minus 17.5, that should be 19. So 19. And there we go. Hopefully this is right. All right.